What's up, Titans? A little Beaver fever to get us going here. Make sure we got that journal open to page 257. We're working on section 8.3, our notes. This is Mr. Wills coming at you for a little Algebra 1, talking about finding the vertex and graphing quadratics. So let's go ahead and talk about some definitions here. The first one is the maximum value, and we want to write in a little definition here. The maximum value is the y coordinate. So it's the y coordinate, or the y value, of, oh my goodness, what is going on here? Of the vertex, the y coordinate of the vertex of the graph of f of x equals a negative ax squared plus bx plus c. You'll notice that a is negative. So then when we have a minimum value, that's the y coordinate of the vertex of the graph of f of x equals a positive ax squared plus bx plus c. So you'll notice there on when it's a maximum, we have a is negative, and when it's a minimum, a is positive. And we can kind of think about that because when we graph it, when a is negative, it opens down, and the y values at the vertex here, well, that's the max. And when it opens up, when a is positive, we have a vertex there at the bottom, which means we have a minimum value. So those are our two definitions. Hold on to that. We'll come back to that in a little bit. If you need to pause, write those in. Feel free. Otherwise, let me clear the board here, and let's move on down here looking at these core concepts. So the core concepts here, when we're talking about graphing, ax squared plus bx plus c. And a, b, and c will end up being numbers. Well, we just talked about that. It opens up if a is positive, and it opens down when a is negative. Also, the y-intercept is c, so where it crosses the y-axis over here is at c, that number, that's at the end. And then the x-coordinate of the vertex is at negative b over 2a. This is going to be very important that you remember this one. So the vertex, if we're talking about the point that vertex is at, we're talking about the x value is at negative b over 2a. We'll talk about here in a second what the y value is. Turns out that line of symmetry right here, that is at the same line. It's actually at x equals negative b over 2a. Might want to make a point here that to find the y coordinate of the vertex, you just need to plug x back in. So you plug x back into the equation. Okay, so it turns out our point is at negative b over 2a, comma, f of negative b over 2a. All that means is we plug it back in. Alright, so we're going to talk first a little bit about how to find the vertex, then we'll get into some graphing problems here in just a bit. If you need to pause, make some notes, feel free. Otherwise, let's go down to the notes section. You guys don't have to move anything. I've got to scroll down a little bit. Alright, we're going to do two examples here in our notes section. And the first part, we need to find two things. We'll find part A is the AOS, or the axis of symmetry, and part B is to find the vertex. Okay, so two things we want to find here in our problems. Here we go. First example problem. We have f of x equals 2x squared plus 8x minus 1. Okay, 2x squared plus 8x minus 1. Now we know to find the AOS, if we remember, we had to do x equals negative b over 2a. Well, I need to know what b and a is, so let's look at that. On this one, a is 2, b is 8, and c is negative 1. It's just the numbers right in front. So part A here says to find the AOS. So we'll go ahead and make that x equals negative b, so we make that negative 8 over 2a. a, which is 2. So I just plugged these numbers right in, which gave me negative 8 over 4, or negative 2. So the AOS is x equals negative 2. Found my axis of symmetry. Turns out that x value is also the x value of the vertex. So for part B, I already know what the x value is, so I can plug it in as negative 2. I need to find the y value. To find the y value, we plug that in to our equation. So 2 times negative 2 squared plus 8 times negative 2 minus 1. And what do we get here? We got to use little order of operations. Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16 minus 1. 8 minus 16 is negative 8. Negative 8 minus 1 is negative 9. So our vertex is at negative 2, negative 9. So our other answer is our vertex, negative 2, negative 9. So we were able to find both the axis of symmetry and the vertex right there. Let's do another example. So we go ahead and make another example right there. And this time, let's do g of x equals x squared plus 6x plus 5. Here we go, another example. Part A, find the axis of symmetry. Oh, what do we have to do first? Let's hold off a sec. We got to make sure we label what each one is. So A is, in this one, if there's nothing in front of x squared, it's actually 1. B is 6, and C is 5. Now we have those labels, so we can go ahead and jump in and find the axis of symmetry. X equals negative b over 2a, so negative 6 over 2 times 1, which is negative 6 divided by 2, or negative 3. So x equals negative 3 would be that vertical line at negative 3. Part B, we want to find the vertex. Well, I know it's at negative 3. What's the y value? I got to plug it in. Y equals, plug in negative 3. Make sure you put it in parentheses. Negative 3 squared plus 6 times negative 3 plus 5. Here we go. What's negative 3 squared? 9. 6 times negative 3, negative 18 plus 5. 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. So our vertex was at negative 3, negative 4. And there is our answer. So we just were able to find the axis of symmetry and the vertex. So now if we were graphing those, we would go ahead and put those on the graph. We'll come back, graph those in a second here. Let's look next at talking about maximum and minimum values. So we'll go ahead and flip the page, maximum, minimum values. The y-coordinate of the vertex of the graph is the maximum value if a is less than 0, and it's the minimum value. We talked about that. So how would we actually do this? Well, let's do a couple examples here. In your notes section right there. Find the maximum, minimum, okay? Find max or min. Well, let's go ahead and do the first example. For the first example here, when we find the max or min, we're going to do f of x equals negative 4x squared minus 24x minus 19. Well, what do you notice right away? A is negative 4. When it's a negative, that means we have a max. So where is our maximum at? In order to figure that out, we have to figure out what the x value and y value is of the vertex. So to find the x, we do negative b, which is 24, over 2 times negative 4. Negative b over 2a. We get 24 over negative 8. 24 over negative 8 is a negative 3. Sorry about that. Negative 3. Now to find the y value, because this will answer our problem, we go ahead and plug that in. So we get negative 4 times negative 3 squared minus 24 times negative 3 minus 19. And negative 3 squared is 9. 9 times negative 4 is... Where am I at here? There we go. Negative 36. Negative 24 times negative 3 is a positive 72. and then negative 19, and negative 36 plus 72 is 36. 36 minus 19 is 17. So the y value is our max, so we have a max at 17. So we found the maximum value there. Pretty exciting. Let's do one more. Like this. Here we go. Let's say that we have g of x equals 8x squared minus 8x plus 6. Well, notice it's a positive 8, so that means we have a minimum. Where's that minimum at? Let's figure it out. We got to find the y value. First, you have to find the x value. X equals negative b over 2a. 8 over 2 times 8, which is 8 over 16. Oh my gosh, we have a fraction here, 1/2. That's alright though. Let's plug it back in. 8 times 1/2 squared minus 8 times 1/2 plus 6. 1/2 squared is 1/4. 1/4 times 8 is 2. 8 times 1/2 is 4, so minus 4 plus 6. 2 minus 4 is negative 2, plus 6 is 4. So our minimum value is at 4. So to find the maximum and minimum value, we actually have to find the x value first, and then the y value. Alright, some good stuff there with finding the line of symmetry, the vertex, the minimum, maximum value. Now let's actually put it together and let's graph. So you might need another sheet of paper here. Maybe just something a little different. I'm going to go ahead and grab some graph paper here. So what we want to do is we want to graph, there it is, f of x equals 3x squared minus 6x plus 5. Alright, in order to graph, we need to use those things we found at the beginning. We need to find, first, what's a? A is 3. What's b? Negative 6. And what is c? 5. Just label those right away. So what we need to do is we need to find the axis of symmetry first. Axis of symmetry, we know it's x equals negative b. If it's a negative 6, it's actually going to be a negative 6, which means it's a positive, over 2a. Whoops, wrote that backwards. Should be 2 times 3, which gives us 6 over 6, or 1. Ooh, I like that. So our axis of symmetry is at x equals 1. Then we need to find the vertex. Alright, so I know it's at 1 comma something, so I need to find the y value. So let's plug 1 back in. 3 times 1 squared minus 6 times 1 plus 5. We get 1 squared is 1. 3 minus 6 plus 5 gives us 3 minus 6 is negative 3. Negative 3 plus 2 or plus 5 is 2. So we have a vertex at 1 comma 2. Well, let's go ahead and graph this a little bit. So we have a vertex at 1 comma 2, which also means we have a line of symmetry at that 1. So I got to draw that dotted line in there at x equals 1, draw my line of symmetry. And now I know that it's going to open up because a is 3, but I need to find more points. So we go ahead and make our xy chart. And we'll start with the vertex, and then we'll go 2 numbers bigger, so we'll go 2 and 3. Because if I find 2 to the right, then I find 2 to the left. So I know that 1 is 2. Now we've got to plug in 2, so I might do some scratch work. I'm going to plug 2 in to the original equation. 3 times 2 squared minus 6 times 2 plus 5 gives me 4 times 3, which is 12. Minus 12 plus 5 gives me 5. So I get another point at 2 comma 5. So I go over here, 2, 1, 2, 3, 4, 5, make a point. And then at 3, I'm going to plug in 3. So I'd go 3 times 3 squared minus 6 times 3 plus 5. 3 squared is 9. 9 times 3 is 27. 6 times 3 is 18. So I get 18 plus 5. 27 minus 18 is 9. 9 plus 5 is 14. So then I get a point at 3 comma 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 goes all the way up here. Now whatever happens on the right side of that line of symmetry also happens on the left. So I have a point at negative, or at 0, 5, and at negative 1, 14. Connect those with a U. And there's my graph. I graphed my parabola. So graphing a parabola, the last thing we're going to do today. If you got to go back, watch that, rewatch that one more time. Would like you to test a few of these if you get a chance in your student journal. Page 258, so the same page here. See if you can do numbers 1, 3, 5, and 9. Best of luck to you. Thanks for listening. I know it went a little long, but hopefully you followed along. We're able to write down what we were writing down, and let's rock and roll. Good night, Titans.